Okay, we're going to do a couple of examples where you put everything together and then draw the graph. So the first one's the one that we worked about half of in class. So we're going to kind of go over that one very quickly and finish it. And then we're going to do a second example pretty quickly. All right, so that you can just kind of see what I would want on your test. All right, so let me share my screen with you and pull up this PowerPoint. So we're going to kind of start back with the one we had in class. Okay, so here's our example. So we have 2 times the quantity x squared minus 9 divided by x squared minus 4. So remember, to get domain on a rational function, you take that denominator and set it equal to 0. So we said x squared minus 4 equal to 0 and solved it. And we got 2 and negative 2. So that's why our domain was all real numbers except x cannot be 2 or negative 2. Now you can use algebraic notation, you can use interval notation, whichever you prefer, okay? Then remember, you have to find the intercepts, the x-intercepts and the y-intercepts. So to find the x-intercept, you let y be 0. So I went up here and just put a 0 in for that y. And I've got a fraction equal to 0. Now, when is a fraction equal to 0? When the numerator equals 0 and the denominator does not equal 0. So I just set this numerator equal to 0, distributed that 2, added 18 to both sides, divided both sides by 2, and got x squared is 9. So of course that meant x was a positive or negative 3. Now remember, I want your intercepts as points. So you already told me that the y was 0. So it's the point negative 3, 0 and positive 3, 0. So those are our x-intercepts on our graph. So we've already got 2 points now. All right, what about y-intercept? Well, to find the y-intercept, you let x be 0. So I went up here and substituted 0 in for both of those. So that gave me 2 times a negative 9 is a negative 18. And then I had 0 minus 4, so a negative 4. So I got a positive 9 halves. So 0, 9 halves is my y-intercept. So far I've got 3 points ready for my graph. Now I'm going to ask you to check for symmetry, like x-axis symmetry, y-axis symmetry, and origin symmetry. And remember, to check for x-axis symmetry, you're going to replace y with a negative y. All right. So I replace y with a negative y. Now that does not look like the original. But before you write no, remember, multiply through by -1 and see if that'll change it. I mean, that would change that to a positive y and fix that, but it would mess up this side. So that doesn't help. So it's still no. To check for y-axis symmetry, remember, you replace x with a negative x. So I'm going to square a negative x. Well, see, that's going to give me just x squared. So I do end up with the original. This looks just like my original. So yes, I've got y-axis symmetry. Remember, to check for origin symmetry, you replace both. So I replace y with a negative y and x with a negative x, and I got this. And again, that does not look like my original. So I'm thinking, well, maybe I can multiply through by -1. That would fix this, but see, again, it would mess up that. So the answer is still no. So the only symmetry that I have is y-axis symmetry. And that'll be helpful when we go do our t-table in a few minutes. Okay. Now we need to find out about increasing, decreasing maxes and mins. Now remember, that comes from first derivative. Now I'm not really crazy about doing a product rule in the middle of a quotient rule. So personally, I'm going to distribute that 2. Okay. And so I'm going to end up with 2x squared minus 18. Then I can do quotient rule. The bottom times the derivative of that numerator, which is just 4x, minus that numerator times the derivative of that denominator, which is just 2x, all over that denominator squared. Now, you can freeze this, do the derivative yourself, and then double check and make sure that we got the same thing. And I want you to have it in your notes. Okay, so don't just watch it, take notes. All right, so either take the notes and then do it, or vice versa. All right, so I looked and noticed that I could factor a 2 out right here. So I factored a 2 out, and that left me x squared minus 9. And then, of course, 2 times 2x is 4x. So I can factor a 4x out of this term and a 4x out of this term. So that left me an x squared minus 4 in the first one, minus, and then it left me an x squared minus 9 in the second one. And make sure you put those parentheses so that when you distribute, that's going to be a minus x squared and a plus 9 down here. So the x squareds are going to go out. All right, so that's going to leave me a -4 plus 9, which leaves me 5. And then, of course, 5 times 4x is 20x. All right. And then x squared minus 4 factors into x minus 2 times x plus 2, but that whole thing was squared. Now remember that squared goes with everything on the inside. So that x minus 2 is squared and that x plus 2 is squared. So then I made my split point table. So I've got 20x for a factor. That split point, that's 0 when x is 0. So I went over here, and drew my little line. Substitute in a smaller number like -1. 20 times a -1 would be a -20. Substitute a positive number in like 2. 20 times 2 would be 40, and that's positive. Now, the split point for x minus 2 quantity squared is a positive 2, but it's squared, so it's going to be positive all the way across. Similarly, the split point for x plus 2 quantity squared is a -2, but again, because that factor is squared, it's going to be positive all the way across. It's just going to be 0 at the split point. Okay, so then I'm gonna say, this times this, and then divide by that. So I've got a positive times a positive is a positive, and a negative divided by that positive is a negative. So I'm just following what it tells me to do with those factors over here. All right, same thing here. I'm going to have a negative at the final answer. Everything's positive over here, so that final answer is going to be positive. So my function increases here from 0 to 2, union 2 to infinity. Something strange may be happening at 2, so I'm going to skip over that in case. And it decreases over here from -infinity to -2, union -2 to 0. Now think about it. If it's going up, excuse me, let me try that again. Let me clear that real quick. If something's coming down and then it keeps coming down, you're not going to have a max or min here. But if something's coming down and suddenly it turns and goes up, wouldn't you have a minimum right there? So there's a relative minimum at 0 comma something. And again, it's increasing and it keeps increasing. So nothing is going to happen like a max or min there. So I don't have any relative maximums, and I've got a relative minimum at 0 comma something. So I plugged 0 back in that original and got 9/2. Actually, I just remembered on the previous one, I did 9/2 when I was getting my y-intercept. So that saved me a little bit of time. But to get those y values, remember, you substitute back in that original. Now let's go do concavity and inflection points, and that deals with second derivative. So there was my original function, and there was my first derivative. Now notice what I did. I didn't use my factored form on my first derivative to get my second derivative, because again, I didn't want to be doing a product rule in the middle of a quotient rule. So just go back to a friendly form of your first derivative in order to take your second derivative. So I did denominator, I just copied it down. The derivative of 20x is just 20, and then minus that numerator 20x. Now remember the derivative, that 2 is going to come down. That expression stays the same. The power goes down by 1. But then remember, I've got to do the derivative of the inside. And the derivative of x squared minus 4 is 2x. Okay? So I just multiplied this up. This 20x times 2 is 40x. Times another 2x is going to be 80x squared. So then I noticed I had a 20 here, and I can factor a 20 out. So I factored a 20 out. Then I've got an x squared minus 4 squared and x squared minus 4 to the first. So I factored out the smaller power to the first. So on this first term, I needed 2 of these, and I had 1, so I needed 1 more. And then minus, there's my 80, my x squared minus 4 is already there, and I need an x squared, and then I need a 4, because 20 times 4 is going to give me that 80. All right. Then that first parenthesis wasn't doing me any good, so I dropped it off and had an x squared minus a 4x squared gave me a -3x squared, and then I had that minus 4. Now, you don't have to do this. It just seemed easier to me to factor out a negative and make that a -20, and then my 3x squared plus 4 was just a nice little factor. Okay? So my -20 was a factor, didn't have a split point. -20 is just always negative. Now, 3x squared plus 4 doesn't have a split point. Think about why. Because 3x squared plus 4 would have to equal 0 when 3x squared is a -4. And when are you ever going to square something and get it negative? See, you're not. So you can plug in any number you want to. 0 is an easy one. 0 plus 4 is 4. This thing's just positive all the way across. And then this time I have cubed ones. Now, how did I get the cubed one? Here's how I got the cubed one. I noticed right here when I did this that I had an x squared minus 4 up here, and I had 4 of them down here. So what I did was I thought of this fourth one as 1 and then 3 more, so that I could divide out this one with this one. So that left me the 20. And then, like I said, I factored the negative out and made it a negative 20, 3x squared plus 4. And then remember, x squared minus 4 factors into x minus 2 times x plus 2, but they're both cubed. So I have an x minus 2 cubed. So the split point is 2. All right. So if we substitute in a number that's easy, like 0, 0 minus 2 is a negative 2. And when you cube a negative, it's negative. Then when I put a number in there like 3, 3 minus 2 is 1, and 1 cubed is positive. Okay. Then I did the same thing on the x plus 2 cubed. That split point was a negative 2. So I substituted a smaller number like negative 3. Negative 3 plus 2 was a negative 1, and a negative 1 cubed was negative. Then 0 is an easy number bigger than negative 2. So 0 plus 2 is 2, and 2 cubed is 8, and that's positive. So again, notice I've got a negative, a positive. When I multiply those, I get a negative. A negative times a negative is a positive, and then my negative divided by my positive was a negative. And then here, when I multiplied those all up and divided, I got a positive for the final answer. And here I got a negative for the final answer. So you can just pause it and double check me. So it's concaving up between negative 2 and 2. And it's concaving down here, negative infinity to negative 2, union, it's hard to see, and then 2 to infinity. So you have inflection points where the concavity switches. So I thought I had an inflection point at negative 2 comma something at 2 comma something. Then I remembered, oh wait, negative 2 and 2 are not in my domain. So I apparently don't have any inflection points because my candidates didn't work. Okay, if you plug in 2 and negative 2, you're going to get undefined. You don't have any points there. All right, so let's go look at the asymptotes. Now remember, how do you get vertical asymptotes? Vertical asymptotes are numbers that make that denominator 0 that do not make the numerator 0. So I set x squared minus 4 equal to 0 and got 2 and negative 2. And I substituted those in, and I got negative 10 on the top and 0 on the bottom both times. So they both checked out. I got 0 on the bottom and a non-zero number on the top. So x equals the numbers that I plugged in are vertical asymptotes. Now remember, how do you check for horizontal asymptotes? You take the limit as you approach infinity. And again, I multiplied that out to make my life easier. Remember, our technique is to divide by the highest power in the denominator, not in the whole fraction, but in the bottom, which was x squared. So all 4 terms got divided by x squared, and then I cleaned them up. 2x squared divided by x squared was 2. X squared divided by x squared was 1, and then those wouldn't clean up. And remember, the limit of a constant is just that constant. So that's why that stays a 2 and that stays a 1. And then here, when those bottom numbers get bigger and bigger, but you've got constants on the top, you get zeros. So I got 2 divided by 1, which is just 2. So my horizontal asymptote is going to be y equals 2. Okay? So let's go put all that together and then draw it. So I just kind of rewrote it. My domain was all real numbers, but 2 and negative 2. My x-intercepts were negative 3, 0, and 3, 0, and 0, and 4.5. So I went ahead and put those on my graph. There's negative 3, 0. That's 2. Okay. So what you'll see me do is this. I've got y-axis symmetry. I know where my function increases and where it decreases. I know I've got a relative minimum. I know where it concaves up and down, and I know where I've got asymptotes. So what I normally do is put my asymptotes first. So I went and did dotted lines at x equals negative 2 and x equals positive 2 and y equals 2. Then I put the points on that I knew. So I put my negative 3, 0 and my 3, 0 and my 0, 4.5. All right. Then I needed some more points. I didn't feel comfortable, so I went and made a t-table. So I substituted in like a 1. Okay. So 1 squared is 1. 1 minus that 9 is going to be a negative 8. So I'm going to get a negative what? Let's see what I'm going to get. Like a negative 16, and then divided by this negative 3. So I got about 5.3 when I plugged in a 1. Well, now remember, this thing has y-axis symmetry. So remember what that means. When you replace x with a negative x, it stays the same. So when I replaced x1 with a negative x, a negative 1, the y value stayed the same. I didn't have to do all that substitution with my scientific calculator again. So I just grabbed some points. I plugged in 2.5 and got about negative 2 4/10. I plugged in a 4 and got about 1 1/6. So you can, again, stop the video and double check and see if you agree with me. So I went and graphed those points. So negative 4, about 1 1/6, positive 4, about 1 1/6. All right. Then at negative 1, I got about 5 3/10, and at positive 1, I got about 5 3/10. Now, because I knew I had asymptotes, that's really all I needed to draw the graph. If you need more, then get more points on your t-table. So that's the finished product of what we had for the one in class today. Okay. So now let's go do a new one. All right. So look at this example 2. Here's our graph. Negative 3x to the 5th plus 5x cubed. So it's a polynomial, so my domain is just going to be all real numbers. I didn't have to worry about anything. Now remember, to get the x-intercept, we let y be 0. So I put a 0 right there for y, and I had this little polynomial, so I just factored it. So I pulled out a common factor of x to the 3rd. That left me a negative 3x squared plus 5. So either x cubed is 0 or a negative 3x squared plus 5 is 0. So when I took the cube root of both sides, I got 0 over here. When I added 3x squared to both sides, I got 3x squared was 5. So I divided both sides by 3. So x squared was 5/3. Then I took the square root. So I got a positive square root of 5/3 and a negative square root of 5/3. So x is 0, and then the square root of 5/3 and a negative square root of 5/3. Remember your y coordinates. So I've got 3 x-intercepts. Now, I punched it in my calculator and got about a 1 3/10, a positive or negative 1 3/10, because I'm going to need to know that when I go to actually graph it. Now, how do you get the y-intercept? Remember, you let x be 0. So I just substituted 0 in there and got 0 back out. So 0, 0 is my y-intercept. So already I've got 4 points. Now, again, check for x-axis symmetry, y-axis symmetry, and origin symmetry. So when I replaced y with a negative y up there, it did not look like the original. And I multiplied through by a negative 1, and that did not fix it. So no. To check for y-axis symmetry, I replaced x with a negative x. Remember, that worked for us last time, but it doesn't work for us this time. So you can pause the video and double check it. But origin symmetry did work. I replaced y with a negative y, and I replaced x with a negative x. And when I did, I got this. Now, that didn't look like the original, but I multiplied through by a negative, so the opposite of a negative was a positive. That turned that one into a negative. That turned that negative into a positive, which did look like the original. So this time I've got origin symmetry. And again, that's going to be handy to know when I go make this t-table. Okay? All right, so let's go get our increasing decreasing. Remember, that deals with first derivative. All right, so my first derivative, that 5 comes down, so I got a negative 15x to the 4th plus, then I got a 15x squared. So I could have pulled out a positive 15 or a negative. I just kind of like my lead term to be positive, but that's just my personal preference. Okay, but then it left me x squared minus 1, which factors more into x minus 1 times x plus 1. So you may see 3 factors. I saw 4 factors. I saw a negative 15, which is negative all the way across. I saw an x squared. Now that split point would be 0. Let me go put that on here. All right. So that would be a split point, but it's not going to matter because remember, something squared is positive all the way across except right there at the split point. The split point for x minus 1 was 1. So I substituted a number in smaller like 0, and 0 minus 1 was a negative 1, so it was negative. Then I substituted a number in like 3, a bigger number, and 3 minus 1 was 2, and it was positive. Then my other factor was x plus 1, and the split point for that one's that negative 1 right there. So I plugged the number in smaller like negative 2, so negative 2 plus 1 is a negative 1. Then an easy one would be 0, 0 plus 1 is 1, so it's positive. Okay. And then remember, I'm just multiplying. So A negative times a positive is a negative times another negative is a positive, and a positive times a negative is a negative. So my final answer is negative. Here, I'm going to have a final answer that's positive, and here I'm going to have a final answer that's negative. So this thing increases from -1 to 1. It decreases from negative infinity to -1. It also increases from 1 to infinity. So that's where I got this increasing and decreasing. Now think about it. If you're coming down and suddenly you turn and go up, what would you have right here at that turn? Wouldn't you have a relative minimum? So that's how I knew I had a relative minimum at -1 comma something. And similarly, if you're going up and then suddenly you turn and go down, right there at the turn, wouldn't you have a relative max? Now, how did I get these y values? I substituted -1 into that original, and then I substituted +1 into that original. So again, you pause the video and copy that down and double check and make sure that -2 and +2 are correct, because I could have made a careless error. All right. So first derivative deals with increasing, decreasing, maximums, and minimums. Now let's go get our concavity. All right, that deals with second derivative. So that was our original, that was our first derivative. So now let's do second derivative. So that 4 comes down, so I got a -60x cubed plus that 2 comes down, so I've got 30x. And again, I have to factor it. So I could have pulled out a +30 or a -30. I just arbitrarily pulled out a -30, and then I can pull out an x. So I got a 2x squared minus 1. Now, if you don't want to fully factor this, you could just use this one factor with 2 split points. But remember, if you're going to use the quadratic formula to factor, it's always going to be x minus something. And then your other factor is also going to be x minus something. So to get the two numbers that go here and here, I just went and solved quadratic formula, or I went and solved this the same way. And I got a +1 over the square root of 2 and a -1 over the square root of 2. But now remember, the square root of 1 is just 1. And the square root of a fraction is the square root of the top over the square root of the bottom. So that's how that square root of a 1/2 turned into 1 over the square root of 2. So that +1 went there. When I put that -1 minus a negative made that positive. So I had 4 factors: -30, which is negative all the way across. I had x, so that split point was 0. So it's negative to 0 and then turns positive. Now, I had to go to my calculator and figure out what 1 divided by the square root of 2 was. So I could think of a number smaller and bigger, and it's about 0.7. So that means this would be about a -0.7. So like a -4 would be easy. So if I plug a -4 and I subtract more, that's going to be negative to there. Okay, let me fix this. Let's see what we've got. All right. So if I go all the way up to here, I'm going to get negative and then positive. All right. So if I plug a number in like 0, 0 minus anything is going to be negative, then it turned positive. Then I went to x plus that and plugged in the number smaller. So about a -10. So a -10 plus this tiny little number is going to be negative, but then 0 plus that would be positive. So again, my final answer here is positive. My final answer here is negative. My final answer here is positive, and my final answer there is negative. So, you're multiplying all that up. A negative times a negative is a positive times a negative is a negative, and a negative times a negative is a positive. So I'm not going to bore you with all that. You can freeze it and double check me. So it concaves up from -infinity to that -1 over the square root of 2. It also concaves up between 0 and 1 over the square root of 2. It concaves down between -1 over the square root of 2 and 0. And then it concaves down from 1 over the square root of 2 to infinity. So they have inflection points. The concavity changes here and here and here. So I have 3 inflection points. Now plugging 0 in the original is easy. You just get 0 back out. Now here's what I did. On the test, because you're going to have to graph these, I'm going to let you get decimal approximations for the y values, because we're going to be kind of in a little bit of a hurry. So if you put in like a -0.7, you get about a -1.2. All right. So again, you freeze it and make sure that that's what you got, because again, I could have made an error. Now, what am I going to do next? I've got to go think about asymptotes. But this one, I don't have a denominator to set equal to 0, so I don't have any vertical asymptotes. If I take the limit of this thing as I approach infinity, I'm just going to get an infinity. So I didn't have any asymptotes. So again, I kind of reiterated what I knew from the previous pages. All right. I had some x-intercepts, some y-intercepts. I had a relative max, a relative min. I had some inflection points. I didn't have any asymptotes, so there was none of that to graph. So I went and made a t-table. All right. So I plugged in 2 down here, and you can double check me, and I got a negative 56. It's hard to see that right there. All right. Now remember, it's origin symmetry, so they both change. So if 2 turns into a negative 2, then negative 56 turns into a positive 56. So it saves me substituting all that again. Now look what happened when I plugged in a 3. I got like a negative 594. Oh my goodness. So I went and graphed them. All right, so I graphed all the points from here along with my max. You know, I had a 1, 2, and I had a negative 1, negative 2 for my max and my min. I had a 0, 0 for my x and my y-intercept. All right, so get decimal approximations for this square root of 5. All right, and so that's a little more, and you know, that's a little more than my 2. So get that decimal approximation there and put your intercepts down. And then what I normally do is look at my increasing, decreasing. So it said it was decreasing, and then it turned and increased, and then it turned and decreased. Then I usually go back and fix the concavity because it's supposed to be like a cup sitting up. And matter of fact, I probably would erase and fix this a little bit. It's hard to draw here and make it a little more exaggerated. It's supposed to be like a cup sitting up until it gets here. Then it's like a cup sitting down, then it sits back up, and then it sits back down. All right. So you go back to that slide and check my concavity and check my increasing, decreasing, and see if we agree. So that's what I'm going to ask you to do on your test. All right. All those 9 pieces to draw it. So I'm going to give you some homework for you to try. Okay. Let me know if you need any help.